This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Support for SE Radio comes from the O'Reilly Velocity Conference. Join over 2,000 developers and engineers in San Jose from June 19th through the 22nd to learn how resilience engineering can make your systems more scalable, reliable, and efficient. Get the latest on containers, microservices, infrastructure, cloud, DevOps, systems engineering, security, and more while you meet experts and network with peers. Use discount code SE20 to save 20% on your gold, silver, or bronze pass. That's SE20. Get all the details at velocityconf.com/CA.
Welcome, listeners, to the Software Engineering Radio. My name's Kim Carter. I'll be hosting the show today, and I'd like to introduce Diogo Mónica. Is that how you say your name, Diogo?
That's exactly right.
Cool. Diogo Mónica is the security lead at Docker, an open platform for building, shipping, and running distributed applications. He was an early employee at Square when he led the platform security team. Has a BSc, MSc and PhD degrees in computer science. Serves on the board of advisors of several security startups and is a long-time IEEE volunteer. Welcome to the show, Diogo.
Thank you for having me.
I think it's safe to say that Docker is here to stay, at least for the next few years. There's a lot of concepts it seems that engineers need to get their heads around with Docker in order to understand basically how to set up a secure system, or how to set up secure systems and infrastructure. I'm also working on a book series called Holistic InfoSec for Web Developers, which has several sections around Docker security in it. So I've kind of got some selfish motivation there to learn as much as I can, also in order to create good content for others to benefit from. Yeah. Software engineering host Charles Anderson interviewed James Turnbull on January 2015 for show number 217 on Docker. For those new to Docker, it's probably worth listening to this previous show before diving into this one today. So let's get started. So we're going to be talking about Docker security today, but before we do that, I want to lay some foundations for the listeners who may not be as familiar with either containers or security. Can you give us a quick explanation of how Docker containers work for the listeners, Diogo?
Sounds good. So Docker in itself is not just a container runtime. It is really a platform. But what Docker is most known for is for the container execution runtime component. And so what Docker allows you to do is package everything that an application needs, all the dependencies, all the code, all the resources within this unit that we call an image. And then it allows you to run this image in any operating system you want. So you could run it on Windows, you could run it on Linux, you could run it on your Mac. So effectively makes all of your applications portable, independent of the actual infrastructure is inside of it. And there's obviously a lot of advantages for developers, ops, and security people, and hence why Docker has been very popular.
Can you explain the new Docker Enterprise and Community editions you just mentioned before the show, and what new security features they're bringing, if any?
Yeah, so that's a great question. So Docker Enterprise Edition and Docker Community Edition are very recent. They were launched a couple of days ago. The announcements were today. Effectively, it follows the normal mode or the normal model that people are used to on the open source community, which is there's a open source, community-driven, community-led project that has the major components of the open source. It's an open community. It includes everyone. Everything is done in the open. There's an enterprise edition that effectively has other enterprise features. In the case of the community edition, it's exactly what Docker was yesterday. So nothing changes except from a rebranding. But from the commercial edition, we're now adding to the commercial edition features such as content security scanning. We're adding advanced features around digital signatures and the ability of someone creating a pipeline of images in a CI system that has, for example, multiple signatures, so threshold signing, so on and so forth. So there's a lot of advanced enterprise features, such as authorization and RBAC, that are only going to be able to be found in the enterprise software, and they're also only, in the majority of the cases, useful for big companies. And the community edition continues being what Docker is, this thriving community of developers, ops people, and security people that are just coming together to build an orchestration in a container platform.
The concept of isolation is one that we discussed before the show. I think it's going to be really important to our discussion just to get some concepts basically out in the open before we carry on to some of the other points you raised beforehand. Yeah, so we're going to address some application security, basically once we've covered some isolation topics briefly. So can you define isolation in terms of Docker?
Sounds good. Yeah, cool. From a perspective of computer science, let's call it computer science. Isolation is the ability for you to ensure that an application that is running on your host, virtual machine, or in a more general sense system does not A, affect everything else around it, B, see anything that it shouldn't see, right? So there's the ability of it having resources that it should be allocated and slotted a certain amount of resources, and it should not be able to consume resources of everything that is co-located with it. And it should not be able to see any kind of systems characteristics such in the Linux system, such as the processes or any other information about the system itself. It should effectively feel like it's running on its own individual operating system instead of on a shared operating system. And Docker uses several mechanisms such as namespaces, control groups, capabilities, seccomp, so on and so forth to actually limit applications and make applications feel like they're actually running in their own operating system, even though, as we know, Docker containers are being ran in a parallel fashion, and multiple applications share the same host, the same VM, or the same bare metal.
So why do we care about isolation, and what's the importance of it?
So isolation as a fundamental feature provides effectively the capability of an application that is misbehaving. Imagine that an application is compromised, there's some kind of bug or remote code execution, so on and so forth, or even malicious code. If an application is compromised, then isolation will limit the abilities that this application has and that this malicious code or person has within the system. So if you're running 2 Docker containers on the same bare metal host and one of your applications has a vulnerability, you really don't want anyone with control over this application to affect the other application that is also being co-located side by side. And isolation gives you this guarantee. Not only they can't affect anything else outside of their own boundaries, outside of their own system. So they're effectively isolated.
Cool. So now that we've got a baseline on isolation, if you were an attacker looking to compromise Docker, knowing what the weakest areas are, where would you start and what would be your first targets in terms of the surrounding technologies?
I think as an attacker, I would follow the path that I would also follow to try to escape from anything else, such as a virtual machine or anything like this, which would be try to find vulnerabilities in the systems that are ensuring this isolation. For Docker itself, I would say that the thing that I would search for would be a kernel vulnerability that would allow me to do what we call an escalation of privileges. So some kind of kernel vulnerability on a system call of Linux that, since Docker shares, multiple Docker containers share the same kernel, then it would allow me to effectively escalate privileges outside of my container to actually gain ownership, as we call it on Linux, root over the whole system. And so this would be my first focus, the Linux kernel. Okay,
so I'm going to address each of the areas in turn that you mentioned before the show that we talked about. So one of the things you mentioned was that application security is so much more important than container and VM isolation. Can you give us some more detail around what you mean by that?
Yeah, absolutely. So when containers came out 2 years ago, there was a lot of focus on comparing containers with virtual machines. And even though the comparison is pretty obvious just because they both feel similar in the sense that they both make an application feel like it has its own operating system and it's isolated from that perspective, they're actually fundamentally different. They're very different. And so in the beginning, people started comparing them. And by comparing them, they immediately started going and doing security comparisons. So in my field, they started comparing the characteristics of memory isolation of VTD and VTX on virtual machines with the capabilities of isolation of Docker, which runs on a shared kernel. And this distinction is important because the fact that Docker runs on shared kernel means that any vulnerability on the kernel that allows a privilege escalation allows what we call a container escape. And for virtual machines, you also can have vulnerabilities that allow you to escape. But since you have hardware virtualization support, it becomes a lot harder. You're not depending on sharing kernels. But on the other end, a virtual machine is a lot slower. It has to boot a lot of different things, memory management, so on and so forth, things that containers don't need. So containers are 1 or 2 orders of magnitude faster than what virtual machines are. So these capabilities and these systems that we currently have to actually provide security are there and are specific for Linux. So when Docker came out, are specific for Linux. The systems were already there. Docker did not reinvent anything new. We just made it incredibly easy for you to use as a developer and as an ops person to use these Linux security capabilities that were in the kernel for dozens of years, but now in an easy fashion for you to do packaging of your applications.
In your blog post, Increasing Attacker Cost Using Immutable Infrastructure, the overarching theme is that application security is still the lowest hanging fruit for an attacker. And near the end of your blog post, you have a link to Docker security features, which seems to be mostly focused on the isolation features I just mentioned. Why is Docker isolation much less important than AppSec or application security?
So the point that people miss a lot when they think about Docker is that Docker can actually help with their application security. So there's this thing that I've been calling isolation myopia. We talk about container security, people focus on the virtual machine versus container comparison when they actually should be focusing on what actually matters, which is the security of their applications. If your application is compromised, it doesn't really matter if you are running on a virtual machine or you're running on a container. If a malicious attacker has access to your application, it can steal all the credentials of your application, connect to your database, and simply exfiltrate all of your data. So it didn't really have to do anything else. It already had access to your network and all of your credentials because that's what the application does. It did not have to escape the container, the virtual machine, the hardware bare metal. It didn't have to do anything else but simply compromising your application. So this isolation myopia is the focus of people on isolation of the containers when in fact they should be focusing on what do containers do to help my application be more secure. And so this blog post, what I talk about is there's a lot of features in Docker that actually allow you to prevent classes of vulnerabilities, web application vulnerabilities. In particular, the blog post that you mentioned, I'm actually showing that by using read-only containers, so by allowing a container to not be written to, by running a completely immutable container and not allowing an attacker to be able to write to any sort of file system, even an application that has remote code execution becomes a lot harder to be exploited. So we just significantly increase the attacker cost by simply using a characteristic of the platform of Docker itself. And this is what we should be focusing on, is how can Docker help your application be more secure, not necessarily the low components and the fundamentals of how it's actually doing it.
Yeah, applications over the past 15 years in general don't seem to be getting much more secure. We've been trying to educate developers around the issues, but it doesn't seem to be working. Any ideas on how we can improve this situation?
So that's an excellent question. I really feel that the major thing that we can do is ship security by default, which is actually one of the models of the security team here at Docker. So by shipping security by default, what this means is that by the virtue of you deploying your application inside of a Docker container, you're actually getting a lot of security features for free. You're getting the isolation features that we mentioned, but you're getting a lot more. Right now, if you're deploying on an orchestrator like Docker Swarm, you're getting mutual TLS certificates that distribute all of your applications and deploy them in a secure fashion. You're getting an auto-rotating PKI. You're getting secrets management that are encrypted at rest. So you're inheriting from the platform a lot of secure foundations that would have to be built by your engineering team. And if they don't come by default, and if they are not easy to use and easy to operate, then nobody will use them. So I think the major way to go about this problem is how can we put into the platform and turn it on by default security features that help our applications and help our developers.
In our pre-show discussions, you mentioned that you can inspect behavior of an application inside of a container, but you can't inside of a virtual machine. What do you mean by that?
So what I mean is that imagine that you're running an application inside a virtual machine. So at this point, you have a process running. You have your web app application. But now your inspection unit is the virtual machine. So you are looking at the traffic that comes in and out of the virtual machine, at the memory consumption of the virtual machine, at the CPU of the virtual machine, and at the processes, the aggregate behavior of this unit. The problem is that there's a lot of other things co-located inside of your virtual machine that are not your application. You have a lot of just operating system processes. You have memory being used for X, Y, and Z that is not related to your application at all, except that it's needed by the operating system. It's the fundamentals of the OS running inside the virtual machine to support your application. But when you're talking about containers, what you're actually talking about is you have the smallest possible wrapper around your application. The kernel is the same, the OS is the same. And so by inspecting the running process, that is effectively what the Docker container that is going to be running is, you can have a way smaller unit of inspection. You have this application, the behavior of this application, the memory consumption of this application, the system calls of this application, not the system calls of the whole OS. No, just the system calls that this application is doing. That actually changes the game when it comes to security tools and IDSs, intrusion detection systems, and IPSs, intrusion protection systems, and so on and so forth, because the number of false positives that you're going to have, or the machine learning training that you can have when you're just training on this specific application instead of the combination of what the application does plus the operating system, it allows you to have way better tools, and it's just a way better source of data.
So my thoughts around that comment were that in virtual machines or VPSs in general, we have application logging, instrumenting from within, and instrumentation externally. Is there any reason why we shouldn't use the same tools, or are there offerings more specific to containers that we can use to inspect application behavior? And if so, what are they?
So there's definitely startups now that are focusing on containers, and they're taking advantages of the fact that it's very easy for you to now see network traffic and system call behavior on a per application level instead of per host. So there's definitely companies that are using these new facts and these new capabilities. And the fact that at the end of the day, a Docker container is a process. And in the Linux world, we know exactly how to inspect and monitor processes. And so this smaller unit is being used by companies to create better products, and especially with the explosion of machine learning and the ability to use deeper kernel networks or deep networks, or even the ability of using just simple things like clustering and k-means and all of that allows people to just tackle the problem from a different angle. So ignore the past 15 years of IDSs and look at network traffic, and now come into the world where what actually matters is monitoring system calls and monitoring it at the smallest possible unit. So yes, we are seeing different companies use these new tools and use new monitoring tools that are actually reusing the past 25 years of Linux monitoring, but they're definitely being targeted, and they're being used by these companies to provide what hopefully is going to be better security products.
So what are some of these tools?
So some of these tools, you can think of sysdig is a tool that runs on any Linux operating system and allows you to inspect processes. And it's now perfect to inspect the behavior of your application, because a container actually now is one application. And multiple containers that have the same image running on multiple systems across your infrastructure should have the same pattern of behavior, because they effectively have the same function. The other thing is that there are tools that now allow you to monitor not just this specific application, but how applications are actually operating together. So if you look at something like Docker Stacks or Docker Compose, where you no longer say my application A is running in isolation, you're actually saying no, application A should be talking to database B and should be talking to this side key value store, such as Redis, and these are the three components of my application. Now, a security tool can actually look at this compose file or this Docker stack and understand that there's some communications that should be allowed, some ports that should be allowed, some kind of patterns of communication that should be allowed in our natural, and other patterns of communication that make no sense in this architecture that should be alerting on. So the normal tools that you've had in the past allow you to monitor this, but there's new tools such as Sysdig, there's new security companies such as Aquasec and StackRox coming into the game and delivering solutions that are container specific and are taking advantage of this new, more fundamental unit.
So one of the other pre-show comments that you mentioned was that containers win due to the observation and immutability. Can you explain the immutable copy-on-write file system and how it helps us and how we can take maximum advantage from this?
Yeah, absolutely. The immutable copy-on-write file system is actually pretty interesting. So the base concept is that the file system itself is immutable, and whenever you write anything else to the file system, what it actually does is it creates a layer on top of the current existing file system and writes it to that. So these file systems are layered. They have multiple layers, and each layer effectively adds or removes something to the file system, such that what the container at the end sees is the combination of all these layers in aggregate. The reason why this is really cool is because you can have shared layers. So you could install your base operating system image on one of the layers and then share them across all of your containers, and then just add different applications on top of this. So Docker, one of the reasons why it's so efficient is because it shares these layers and these operating system and base layers across all of your containers, and so allows you to not have to either download them across the network, and just simply when they're built, they can already be reused and included in your containers. The other reason why this is really exciting is, in terms of immutable infrastructure per se, is that you can actually disable writing altogether. So you can say that this container has or should have no ability to be written to. And this is something that I've alluded before, which is by running a completely read-only file system, you have the ability of not having the application write, which gives you really interesting guarantees when it comes to security. But even if you don't run it in that mode, the fact that it is copy on write allows you to do something really interesting, which is an application runs with a specific layer and a hash, a secure hash that you know what it is when you're running it. And then every modification, you can actually inspect and at runtime do something that in the Docker world is called a Docker diff. It's a Docker diff command to see what files were changed since I ran my container. And so this actually allows you to do super cool things like incident response in the case that your application is compromised, or simply just see what the behavior of the application is. What is it writing to? What log files does it need? Is it uploading something that it shouldn't? Did it modify some kind of file on disk that it shouldn't have? So on and so forth.
Okay, so you mentioned pre-show that you can't run a VM with the read-only flag, but with Docker it's trivial. Can you explain for listeners the context of that conversation and what you meant by that?
So there's a lot of things that you can do in the virtual machine world, but are just not easy. It is not easy right now for you to set up a virtual machine and just set up the whole virtual machine such that nothing can be written to. And there's several reasons for that. Number one, that's not a feature that just comes built in, as far as I know. But regardless of that, the operating system, there's a lot of things that it needs to do that might be actually writing to files. It's a lot easier for you to have one specific application that doesn't need to write to disk than to have a whole operating system that doesn't need to write to disk. So it's really about, since we're talking about different concepts, since we're not running a full OS, we are only running an application which is effectively on a shared kernel, and it's effectively a process on that same kernel that is running only the application component that it needs with a shared underlying file system and a shared underlying kernel. We can do this. In a virtual machine world, we really can't.
So can you go into a little bit more depth as to why running in read-only is so important for security?
Yeah, the read-only is just one example. Read-only file system is just a proof that you can increase attacker cost in a trivial manner by simply passing one command line flag to a Docker container. So I use it as an example because it's a visceral one, it's an easy one, it's one that is it conduces to very cool demos. So you can effectively have a compromised PHP application with remote code execution, and you can show that by simply turning it into read-only, now an attacker can't download a PHP shell, and it can't just download an exploit that then it would compile it and use it to escape or to effectively gain more privileges on the system. So it's just like a demo. There's a lot of other things that you can do. Seccomp profiles being one of them, so you can limit all the system calls that your application is allowed to do inside of the container. This allows you to effectively limit the surface of exposure that the kernel has. You have Linux security modules that you can use, such as AppArmor and SE Linux, that allow you to have extra guarantees around access to any kind of resource outside of the container namespace. You have the ability, for example, controlling processes such that an application or some C group properties, for example, an application can't do a fork bomb to your whole host, which is something that on a Unix system we're very familiar with for the past 30 years.
My thoughts around those comments were that you can run anything that has a file system that has to be mounted as read-only. Can you explain the fundamental difference of running a container as read-only versus running a VM or any VPS with granular read-only file system mounts? My thoughts are basically that it's just around simplicity and ease of use with Docker containers. Would that be correct?
That's absolutely right. I mean, we've described this before. Docker was built originally on top of the fundamental security features that Linux already provides. Namespaces, control groups, capabilities, Linux security modules, Seccomp, all of these things were already there. Docker is about creating an easy way and a package format that everybody agrees on, and an easy way to run this package format across multiple platforms. That's how it was created. That was the original purpose. And in security, we usually say that if it's non-usable security is not secure. If it doesn't come on by default, nobody's going to turn it on. And if it's not trivial to use, then definitely nobody's going to use it. So the fact that features are accessible and easy to use is effectively night and day.
So what does your logging strategy look like when you're running a container as read-only?
You can do a lot of things, but best practices are to use syslog or to log to a remote location, especially a location that is should probably be append-only, such that an attacker can't really go and modify logs. But that's a strategy that I've seen commonly used.
The concept of container orchestration will be important to our discussion. What is container orchestration?
So when we're talking about Docker containers, what we're really talking about, as I mentioned, is effectively a process running on one host. But running an application on one host is not particularly useful in today's world. What you really need is you need to run this application and have the ability to resist failures of the node, resist downtime, have it replicated across multiple data centers. You obviously want the ability to have it scale in an easy fashion, such that if you have a spike in traffic, you can effectively deal with the extra traffic, so on and so forth. So just to say that there's a lot of need to run applications as a distributed system, not as an isolated unit running on this particular host. There's also the matter of management and effectively resource efficiency. If you have 100 nodes, you don't want to manage manually what applications are running on what nodes. You want a centralized authority that is effectively managing the allocation of hosts, tells you whether you have too many hosts and you have some idle hosts that you could shut down, or if you're actually almost oversubscribed and you need more hosts. So all of this logic of managing multiple applications running on your data centers is controlled by what we call orchestrators. And there's already been orchestrators for other things, but with the beauty of the packaging format and the ease of use and the speed of Docker, container orchestrators are becoming really popular. So having the ability of having containers be deployed across your infrastructure, any cloud, local infrastructure, public clouds, private clouds, so on and so forth, and being managed and orchestrated in a secure fashion from a centralized orchestrator is something that is incredibly powerful.
Can you give us some examples of some of the orchestrators that are available to us?
Absolutely. I think the most popular orchestrators right now out there are, Docker Swarm that comes built in Swarm. Obviously, Kubernetes has gained a lot of traction recently. It was a project out of Google originally. Mesos was the first player in the orchestrators, or the more modern orchestrators. There's also Habitat and a couple of others. I would say that the three most common ones would be Kubernetes, Mesos, and Docker Swarm.
So you mentioned in our pre-show discussion that you thought the orchestration layers were a lot more interesting and impactful company security than isolation concepts. So I'm quite keen to address each of these layers in turn. So basically we talked about a mutual TLS PKI, secrets distribution, least privilege orchestration, content scanning, image signatures, and secure trusted build pipelines. Do you want to give us a bit of a rundown on mutual TLS PKI by default to start with? So just for the listeners, TLS is transport layer security and PKI is public key infrastructure.
Yeah, the reason why I'm so excited about this is before Docker, I worked at a company called Square, and Square was a payments company that was a startup created by the founder of Twitter, Jack Dorsey, and then it effectively became very successful and is now moving $40 billion a year or something of the sort. So over 4 years while working at Square, we had to come up with solutions for problems such as, how do I securely deploy an application? How do I know that the code that my developer committed is the code that is running in production? How do I know that the internet connection between my production server and my version control system is not compromised? How do I know that my build system is building the right things? On another side, how do I actually distribute secrets throughout all of this infrastructure? How do my systems communicate with each other? Do I have a secure way of communication? And do I have identities? How do I know I'm deploying to the right node? Am I just SSHing to a random ID? Does it have characteristics? So there's a lot of fundamental infrastructure problems that we have to solve to be able to simply deploy one application on an infrastructure, all the way from the developer commit to it being built by the pipeline, to being securely deployed, to being securely sent to the host, and all the hosts communicating with each other, and the secrets and resources shared with it. So one thing that we realized that these things are really hard, and security teams all over the world were rebuilding the same things over and over again. And these are the things that actually fundamentally affect your security. There's a lot of things that you have to do in security, but these are the foundations, which if you don't get right at first, you're effectively doomed to have forever. It took Facebook years to be able to actually deploy TLS across their infrastructure. So once you actually have technical debt in this area, it becomes incredibly hard to fight and to actually find time and to change things to actually do the right thing. So one of the things that we focus the most on is security of containers, and the fact that containers are becoming so popular gives us the chance of making or getting it right the first try. So orchestrators should be able to deploy containers and manage containers in a secure fashion. And it should provide everything that a container needs such that the application inside of that container can be more secure. And in particular, you mentioned PKI and TLS. So it turns out that a lot of people use mutual TLS, so mutually authenticated transport layer security, for securing communication between applications and nodes and for solving the identity problem. The identity problem being, how do I know that node A is node A? And the answer is you issue a certificate to node A saying that it's node A. But now you have a problem, which is who issues a certificate? Who's the certificate authority? And so every company out there ends up with their own bespoke solution to certificate authorities and to issuing certificates and having to deal with rotation and revocation and all of this huge mess that nobody really wants to deal with, but it's fundamental for the security of our infrastructure. So what we built into Docker Swarm, our orchestrator, is we take care of those fundamental things for you in a super easy fashion that comes secure by default, and you can't turn it off. So exactly what we discussed, how can we actually improve the security of applications? Well, when you create a Docker Swarm, you effectively have a PKI built for you. So you have a certificate authority that gets generated. The managers of the system, which are privileged nodes on this Docker Swarm, on this orchestrator concept, effectively get issued certificates. And then every time a new node joins this cluster, it gets securely issued a certificate that identifies it. And all of the communications across all of the nodes use mutually authenticated TLS for authorization, for authentication, and obviously for encryption of the payload. And then on top of this secure infrastructure, then we build things like secrets management. So you can very easily, with one Docker command, Docker secret create, add a secret, share it securely with the cluster, and have it distributed throughout all of your applications in a least privileged fashion. And when I mentioned least privilege, the importance of this is that a specific container should only have access to exactly the resources that it needs to do its purpose. no more, no less. And the same goes for the node that is running that container. If that node does not need to run container X, then it should not have access to the privileges that container X has, or any of the resources, keys, tokens, so on and so forth. So by having the orchestrator help you, we can actually get to a world where you have all this substrate made in a secure fashion and follow the principle of least privilege and use best practices such as mutual TLS and automatic certificate rotation and short-lived certificates, all done for you for free.
So the least privilege orchestration, is that set up by default? I mean, can you just go into that a little bit more as to what it actually means?
Yeah, absolutely. So the sad or unfortunate reality is that a lot of orchestrators that came out in the past few years were built in a way that, for example, doesn't come with security enabled by default. So everything is HTTP instead of being HTTPS. So they're vulnerable to spoofing and man-in-the-middle attackers and passive attackers and so on and so forth. Another unfortunate thing that started happening was people started deploying key value stores to effectively have service discovery, and so kind of a centralized key value store that they would rely on for the majority of the state or the things that kept state in their orchestrator. But they did that in a way that it's not encrypted, and they did that in a way that is not authenticated and that is not secure. So when you effectively go down that path, you have the fundamentals be done in a way that when any node joins this kind of orchestrator, they have access to all the resources. So you have 1,000 node system, and you could actually have access to every single secret of the cluster and every single resource, and everything is effectively like within the cluster, everyone is trusted, which is, as we know, it's the wrong approach to take to this. So what we did was when we were designing Docker Swarm, on the drawing board we said, no, this can't be like this. We have to follow a principle of least privilege. And what we mean by this is if a node is compromised, an attacker will only have access to the resources that that node has at that specific moment. No more, no less. And so this allows the manager of the cluster to, if it has 1,000 nodes, to define 10 nodes to run one application that is very sensitive, to define 100 nodes to run another application that is less sensitive, and maybe to define some other set of nodes that actually run an application that is a front-end system and therefore is more vulnerable. And now, if your system that is running your front end, that is the most vulnerable one, gets compromised and somebody gets access to credentials or gets execution on this application, now those nodes effectively only have access to the things that that web application has access to, and they can't simply go and access everything else. So the sensitive applications are still secure. And this is effectively following the principle of least privilege. When they compromise that node, they only have access to what that node has access to, no more, no less. And to do this, we obviously had to build a lot of things into Swarm itself, but at the end of the day, we also wanted it to be completely trivial. So this is the default model in which Swarm runs. You cannot disable the PKI, you cannot disable mutual TLS. Secret management comes encrypted at rest by default, and it comes enabled by default. And so you just have to do Docker secret create and to effectively use secrets management. And all of these things already operate in a least privilege model, which effectively means that the manager chooses what secrets are in memory of which host at which time, and it only sends these secrets if an application that needs them is running. And once the application stops running, it effectively removes the secrets from memory from the host, ensuring that compromise of the node only compromises what the node has access to at that particular moment.
So what are the secrets? I mean, are you talking about secrets? What exactly would you call a secret, and what does the orchestrator define as a secret?
So from the point of view of the orchestrator, a secret is just a blob of data. But very common secrets that every infrastructure out there right now needs are things like TLS certificates, are things like Amazon AWS tokens, usernames and passwords, encryption keys, signing keys. So all of these sensitive things that for the longest time developers have been managing by putting on their versioning control or directly putting on the hosts or disks of the hosts that they are running. So there's been a lot of mismanagement of secrets. I mean, how many times have we seen secret AWS tokens be committed to GitHub and explored by attackers to mine Bitcoin, right? So these AWS credentials, this is on a daily basis being scanned GitHub for credentials that allows attackers to access or compromise infrastructures. And this has come out of the fact that there has been so far good mechanisms for people to manage their secrets in an integrated fashion with the place where they're deploying it. And so this is why we believe this is so important, because by coming by default, Swarm Docker secrets allow you to effectively have a good, decent management that is secure out of the box and avoids people from committing these things into GitHub.
This podcast is supported by Atlantic.net, hosting solution provider of healthcare HIPAA, PCI compliance, and ad tech. If you're feeling the pain of having outdated technology, call Atlantic.net and get the latest security firewall, intrusion detection, backup, disaster recovery, and virtualization. Or if you're starting a new project or not getting the results you want from your current providers, Atlantic.net can help you succeed. With fully audited solutions and 23 years in business, they won't let you down. Visit Atlantic.net to learn more.
So what about the other orchestration tools like Kubernetes and some of the older ones? Are they doing the similar sorts of things by default?
So right now, there's definitely a lot of talk on some of those projects to effectively catch up to what Swarm has been doing and to catch up on this posture of secure by default. But the reality is that it's really hard to bolt on security after the fact. I mean, this is a known motto that we know in the security world. And so for us and for our perspective, we're always willing to help any open source project, and all of them mostly are open source projects, because at the end of the day, what we care about is the security of the users of our users. So it doesn't really matter if you're using Swarm or Kubernetes or Mesos or other orchestrators. What we really want is at the end of the day that the users of the companies that are using these orchestrators get something that makes them safer. And we think that the usability of our orchestrator, tied with the fact that is incredibly simple and that it comes integrated into Docker, is effectively going to be the best way that people are going to deploy their applications. But we're absolutely fine with people deploying applications however they like.
So would you say Swarm's a little bit ahead of most of the other orchestrators in terms of its security stature and the different things that it's implementing around security?
I would definitely say that Swarm, from the design process and from the early beginning, considers security as one of the three biggest, strongest, and most fundamental pillars of the development of it. And I think that shows in the features that have been coming out and what it enables.
Yeah, so you also mentioned content scanning when we discussed orchestration. Can you go into that in a little bit?
Absolutely. So that's another component that is incredibly important on the software development lifecycle of any company. If you're developing content and you are effectively committing code and developing applications and putting them in containers and deploying in our production systems, you want, as part of your CI pipeline and as part of the exact same process that leads a piece of code to go from a developer's computer to a production host running in production, you want that same pipeline to ensure integrity, but to also ensure security of the content itself. So scan for vulnerabilities, look at the content and see if there's particular pieces of software that are out of date. So what we did was we created something called Docker security scanning that effectively builds a bill of materials of all of your containers, layer by layer. So using those layers that we talked about the copyonwrite file systems, Docker security scanning effectively scans every layer and tells you what vulnerabilities might have been there, scans all of the binaries, flattens jars, and really does a bill of materials to tell you this is the current status of your container, this is what's in it, these are the vulnerabilities that are in it, you should probably update them before you deploy. And the reason why this is so important is because for the first time, really ever, we have a unit that represents the image that is going to be ran, and we know how to read this unit, and we know how to scan it for security. So we can do super cool things like rejecting a deploy if this container has vulnerabilities, and automatically scan this container whenever it gets built, spin it up, and do some dynamic testing and some static analysis on the container's contents, and see if it's actually fit for production. We've really never had that, but this rise of what they're calling DevSecOps is incredibly important. And when done right, it really increases the security of all of your software development lifecycle and therefore of your whole organization.
Docker Enterprise and Community Is that coming with the content scanning out of the box?
So for the Community Edition, effectively, a lot of what people do is they pull the official images from the Docker store. And every single Docker store official image actually has been validated and scanned by Docker Security Scanning, and we're responsible to actually verify their integrity, sign them with Notary, which is a tool that we use for content integrity, and then effectively allow you to have access to the highest quality images out there on the internet for Docker, and we give you as part of a Docker store. For the enterprise side, what we give you extra is the fact that you can run on your own images. So you can deploy it either on Docker Store or on the Docker Hub, but you can also deploy it on your own infrastructure. So you can buy Docker Data Center, and Docker Data Center will effectively do the same things for you. So every deployment, every image that you push to Docker Data Center, it will effectively run these scans, build this bill of materials, and alert you of these vulnerabilities. That's effectively what's being added on the Enterprise Edition.
So the content scanning, is it still paid for? I think it may have used to have been that way, and that's why there's quite a few free tools in the same space. Is that correct?
So content scanning for us is definitely a paid feature. It's a paid feature of the private repositories. The reason why it's a paid feature is because this content scanning is a lot more than just looking at lists of CVEs. So there's a lot of open source tools that allow you to do the basics. So look at whether the package manager is telling me if I have a package that hasn't been updated, for example. So this is useful, and it definitely catches things such as a package that should have been updated and it hasn't been. But what we do with Docker Security Scanning is, as I mentioned, is we actually build a bill of materials. So we go through every binary of your system. It doesn't really matter where it came from, if it came from a package manager or not from a package manager. And we find things. Doesn't matter if there's a vulnerable OpenSSL version, for example, or OpenSSL library that was statically linked or dynamically linked. We're going to find this and we're going to alert you.
So in one of our previous discussions, you mentioned how Intel Security Guard extensions, or also known as SGX, along with Secure Container Environment, also known as SCOAN, was going to make an impact on how we employ security in our Docker environments. Let's start with an examination of SGX, and then we can proceed into SCOAN if we get time. So SGX depends on the concept of an enclave. What is an enclave?
So I'm not by all means an SGX expert, but effectively what is happening with SGX, it's actually might be the big thing in coming to the security industry, at least since the introduction of Intel VTD and VTX and TXT technologies, which have been around for a while. So the promise of SGX, and going to your point, is the ability to create this secure enclave even within a potentially compromised operating system. So effectively what it allows you to do is it allows you to run code inside of a trusting enclave and have secure inputs and secure outputs, and allow the operating system itself, because these are hardware enforced guarantees, from actually inspecting what's happening and what's running inside of the enclave, and guaranteeing that all the inputs from the enclave are secure, signed, and all the outputs of the enclave come from the enclave and cannot be spoofed. So effectively allows us to not have TPMs or biases to trust, and allows us to effectively have this super cool property, which is having an SGX enclave means that you can run code in an untrusted operating system, which can be used for a lot of things, Docker containers being one of them. And so the post that I mentioned was actually something that is pretty interesting. It's something called SCOAN. I think it was presented at OSDI in last year, 2016, and effectively looked at Linux containers that are being managed by Docker and tried to find a way of running them inside an SGX such that they could have trusted execution. So they were successful. It has some limitations still, but the early results are really promising.
So do you know how the SGX chain of trust works, and can you explain that?
No, absolutely not. If you want to know details, and if you want to know about SGX, I would recommend that you go and maybe go to The Invisible Things. That blog is incredibly good by Joanna. She's incredibly good at what she does. She explains SGX in a lot of detail, and she's been covering it. She also is part of the teams that builds cubes and does a lot of good work with isolation. There's also the original papers, and there's obviously the references from Intel itself and the hardware components. So I recommend, if you're interested in it, to go check those out.
A monolithic kernel containing tens of millions of lines of code. which are reachable from untrusted applications via all sorts of networking, USB, and driver APIs, has a huge attack surface. It seems that adding Docker into the mix exposes all of these vulnerabilities to each and every running container, thus making the attack surface grow exponentially. Can you explain how the security of libcontainer, which is now the default container format layer, works, and what is to stop attackers bypassing it and attacking the underlying huge attack surface of the shared kernel?
So that's a great question. So libcontainers actually came as a modification to Docker to replace LXC, and now it's actually in the form of runc. So runc is effectively an open source implementation of a container execution engine. I'm actually on the TOB, the technological oversight board of the OCI project, and OCI itself is effectively a body that is standardizing this tool that allows you to span and run containers. And so now what you're referring to as libcontainer is actually all built into runc itself. So it's a battle-hardened, embedded, unopinionated runtime is, if I recall correctly, what we actually called it. And I think I've explained this before, but all of these tools and all these security mechanisms have been in Linux and have been in the Linux kernel for a long time. So if you were running applications on your Linux systems, you were already exposing your Linux systems to these applications. You were just not making use of these security features. So what Docker does is it adds yet another layer of security, and it adds a protective shell around your application that allows you to configure things like seccomp policies and SELinux, so in all of these LSMs and capabilities and remove capabilities and add capabilities and configure cgroups. So by running an application inside of Docker, you're only adding more security. You're almost adding no other exposure. If you were already running an application inside of a Linux system, adding it inside of a Docker container only makes it more secure.
I've seen a good number of reports stating a high number of security vulnerabilities within images on Docker Hub, even up to 90% of official images. Can you talk about a case where a registry a consumer has been compromised due to a vulnerability in an image that they pulled down and spun up?
That's an excellent question. So we actually built something called Docker Content Trust, which uses an open source software called Notary, and that does image signing. And the whole concept there is that you do not need to trust the registry. So you can have offline signing keys as a developer, and you sign your content. And then it doesn't matter what the content is hosted, where it's hosted, if it's coming via HTTPS or HTTP, any running engine that pulls this image can validate that cryptographic key and can validate that the content has been signed and validated by the actual original developer. And you can actually have cool things like threshold signing. So you can sign with multiple keys, and only if these keys, multiple keys, were validated, then you actually execute the container. So on the side of the trust itself, we sign all of the official images, and we sign it with keys that have the root components offline. So we follow the best practices. So pulling from the Docker store and from the Docker Hub content is actually the best way for you to get the best content in terms of containers out there, because we scan it every day, because we actually manually fix the vulnerabilities, and we sign it with the keys. But if you don't want to trust the hub with your own content, then you should use Docker Content Trust. And that is the way to go to effectively remove all of that attacker model that you're describing gets removed by the fact that you're only running signing content.
So can you go into a little bit more detail around the Docker Content Trust?
Yeah, absolutely. So Docker Content Trust was released with Docker 1.8, if I'm not mistaken. It effectively is an opinioned implementation of an open source framework that we call Notary, that we also released at Docker. But what we did was we released Notary independent, in a completely independent fashion, such that other projects can also benefit from this level of security and from these guarantees around signing and integrity. And then we included it into Docker. And our point was, again, how can we make it trivial for people to verify the signatures of an image? And so we integrated it in such a way that if you do a Docker push, it gets signed with a key. And if you use Docker pull, it gets validated with a key. And that's it. By turning it on, you effectively are validating every single piece of content. And if that content is not signed and it's not fresh and it's not valid, then it doesn't get ran. And we went a little bit above and beyond of what the actual status quo was. And instead of using something like GPG that has a lot of issues when used directly or applied directly to a content software update mechanism, we used a framework called the Update Framework. And this framework was actually designed originally by the people that created the Tor browser. They have a very stringent attacker model, which is obviously nation-state attackers trying to get code in there, trying to effectively compromise nodes of people using Tor. And so they had to design a model for their software update that resisted against compromise of online keys, that had properties around freshness guarantees, so on and so forth. And then there was a group of researchers that picked up these original ideas and created it and extracted it into a framework called TUF, T-U-F, the Update Framework. And that was the framework that we based ourselves to create Notary, and that ultimately went into Docker Content Trust. So it's a very sophisticated way for you to do updates of software, and it's totally integrated into Docker and incredibly easy to use.
So does Notary help us with knowing where an image originated from? So if we're pulling an image down from one of the registries?
Correct. If you sign, well, if you're pulling an image from a registry and you're trusting that registry with that image, so if you already pulled from that, you know that it came from that registry. So content ownership is at the level of who signed it originally. So in a way, yes, you can have provenance guarantees by trusting a specific key for your content. And then you know that that content came from the organization or entity that has control over that key, and therefore you know what the provenance of the image is. So you could use Notary for provenance.
So I'm just thinking also, so Docker uses secure hashes or the digest around image provenance, doesn't it? So
Correct.
Can you go into a little bit around how that works?
Absolutely. So we use effectively SHA-256 hashes to describe what the contents of an image is. So what we're actually doing in technical terms is we have a Merkle DAG, which is a Merkle-directed acyclic graph that effectively has all of these pieces of content, all these layers of the file system of the container image, so on and so forth, and all of them get hashed and aggregated into one final hash. That is the top of the tree, and that effectively changes if any bit of any of the other underlying leaves changes. And Notary actually what it does is translates names like Alpine or Diogo Mónica / OpenVPN into secure hashes. That's actually what the job of Notary. It validates signatures that tell you that OpenVPN or Alpine actually corresponds to this hash over here. And so then what Docker does is it does what we call a pull by digest. So we use a content addressable system. And what we do is we download content from a remote host, but we tell the remote host what is the SHA-256 hash of the content that we want. And when the content arrives locally, we know how to verify its integrity because no other content could produce the same hash once we hash the content that it got downloaded. So we use hashes to effectively have a content addressable system that then these hashes get signed by Notary itself to provide the provenance guarantees and all the things that we were talking about before.
So many of Docker's defaults seem to be designed to allow DevOps and developers to get up and running with the least amount of friction and in minimal time. In adopting Docker, are we trading off security for the other benefits of containerization?
That's an excellent question. What I feel is exactly the opposite. I think there are good ways of implementing new technologies, and there are obviously bad ways of implementing new technologies. But as I mentioned before, by the fact that you're running an application inside of Docker, you're only adding another layer of security. You're only adding more abilities for you to control the behavior of the application, for you to inspect the container, the behavior of the application, an easy way for you to inspect the contents of this particular image, for you to scan it, a lot easier way and faster way of deploying updates and patching things, which is critical in the world of security. So effectively, when you go and start using Docker, and there's obviously right ways of doing things and wrong ways of doing things, but by and large, if you start using Docker and you go towards a world where your CI is building Docker containers and towards a world where you're using an orchestrator like Swarm to orchestrate all of your containers and to share all of your secrets, you're going to be in a way better place than you were beforehand. You're going to be in a place where you have the ability to monitor, inspect, rotate, update all of your content in all of your applications, and you can restrict their behavior and you can restrict or improve their security by the underlying platform, where before you didn't have. So it's like everything. There's always a double-sided edge on a blade, and with Docker, there's wrong ways of doing things, But for the majority of the use cases, it's absolutely adding on more security and not detracting from security.
Images derived from other images inherit the same user defined in the parent image explicitly or implicitly. So in most cases, this will default to root. Docker's default is to run containers and all commands processes within the container as root. Was this a decision made with the aim of making things just work?
Well, that wasn't as much of a decision. It wasn't as much of a decision as it was just an historical artifact. I think the thing that we have to realize there is we have 25 years of experience of managing Unix systems. And throughout all of these 25 years, nobody has ever said to any developer or ops person that they should run things as root. This has never been the mechanism. All of these applications already drop root privileges. All of these applications and tutorials already say that running as root is wrong. So Docker didn't actually add anything there. It only allowed you to do exactly what you were already doing before. If you had an application that was already correctly implemented and correctly configured to run as non-root, then it's very easy for you to run it as non-root inside of Docker. Actually, it's incredibly trivial to drop the whole privileges of the whole container by using the user directive to actually make sure you do so. So the fact that we didn't add anything there doesn't mean that we detracted from it. The security of your applications continues in a way, and even though we want to help you, your responsibility. What we did do is we added username spaces that allows you to, even for lazy developers and ops people that don't want to do the dropping of the capabilities, the dropping of the actual UID, so from root to another user, such as nobody, we added username spaces that effectively makes root inside of the container, not be root outside of the container. And this is a daemon side setting that you can enable, and once enabled, all of the root inside of your containers no longer have root privileges and get mapped to different IDs outside of the container. So you can actually, in a very easy way, sweepingly say every application that has been wrongly configured or wrongly made to run as root now no longer has those privileges. Plus, the fact that you're running applications in Docker actually allows you to understand if they're following best practices or not, because you can inspect the Docker file, and you can inspect the image, and you can inspect the actual code and the entry point that tells you how this application is going to be executed. So it becomes very obvious for a security team to create automated scans to say, oh, this Docker image is insecure or should have these added extra parameters or should drop privileges in X, Y, or Z way, which effectively makes you have more visibility and ultimately more security.
So what do you actually use for those types of scans that your configurations are meeting, I guess, best practices?
So we launched something called Docker Bench that effectively follows the best practices of the CIS Docker benchmark. It's been a couple of years. It's been run and pulled millions of times. So a lot of people are using this in these organizations, and effectively tells you in a very easy fashion, instead of you having to read the 150-page best practices recommendation doc, it allows you in a very easy fashion to just show you yes or no. Do you pass this test? Do you not pass this test? Should you be running or change this configuration? Yes or no. As much as we can, we are turning everything in terms of security into a no-brainer choice, and we're turning into the more secure option to becoming turned on by default, and that is effectively the path of Docker.
So in terms of the 6 items that we discussed that were based around Linux, so we've got namespaces, kernel namespaces, control groups, Linux security modules, capabilities, secure computing mode, which is SecComp, and file system mounts. Which of those 6 do you think are the most important that people need to look at and skill up on in order to make their environments more secure?
I don't think people should be looking at the fundamental and the little nitty-gritty details. I think there has to be a way for people to know that by deploying an application inside of a Docker container, it makes it safer. And we already do that because we already ship defaults for all of these things that you mentioned. So we have defaults for SecComp, we have default, less than half of the capabilities on Linux come enabled by default. We have C groups that come on by default. We have default profiles of SE Linux and default profiles of AppArmor. So the reality is that if you want to harden your application further, by all means, you can go tweak the knobs. But for the normal user, we already ship secure defaults. And we're on a path where we continue shipping and hardening these secure defaults and continue shipping software just comes secure by default.
I was looking at capabilities, and it looked like there was quite a few that could have been turned off that weren't. Are you sort of like still looking at reducing that set?
We're always looking at reducing the set, but if you look at the NCC group report on all of the on all of the container runtimes, you're actually going to see that the NCC group that did the security evaluation of Docker versus a few other executor engines concluded that Docker was the safest one. So we're actually leading the pack in terms of security and in terms of dropping privileges and in terms of security by default, and we're going to continue to do so.
Who are the NTC group?
NCC group. It's effectively an independent organization that does a lot of evaluations of different software. So they've done a lot of open source software, pro bono, but they usually obviously charge for people to look at it. And they have an excellent crypto group that's done some very publicly facing evaluations of products out there.
So what interesting personal projects or events do you have on the go currently, Diogo?
So right now I'm really excited about something that we're calling service identities, which is, it's incredibly painful right now for any infrastructure engineer that wants to have mutual TLS between applications in their data center to do it in an easy way. So we're going to give you the ability of creating certificate authorities for yourself in a super trivial manner and give identities for every single one of your containers running in production, obviously taking care of the rotation for you. So these core fundamental infrastructure problems that would take you towards the 0.1% of most secure companies or companies with the best security of the infrastructure. Those are the kind of projects that we're trying to put into the orchestration layer with Docker Swarm, and we're trying to give it for everyone else.
So you're working on that currently, are you? Or is it actually nearing completion? Or
we're working on it right now. We would like to have some really cool demos of it for DockerCon that is coming up in April. It's going to be in Austin. Definitely recommend you be there. It's always incredibly exciting to see the vibrant community and the excitement around Docker. I always leave that conference really, really pumped about the stuff that we're working on. And then I'm also working on a lot of other things. Right now, we're focusing a lot on hardening default operating system that comes with Docker additions. We are working on InfraKit and securing the communication and securing the integration between InfraKit and Docker Swarm itself, which is yet another component of Docker. And there's a lot of other juicy stuff that I think I shouldn't talk about because it's going to take a little bit away from the surprise. And we love to surprise our users with really cool, easy features.
So what have we not discussed that we really should have for our listeners?
I think we covered a good amount. I think it's pretty obvious that at this point, Docker has matured when it comes to security, that we are providing a lot of cool features for people's infrastructure, that people get it for free. And so there's really no reason for you not to be using Docker. It's interesting that in 2 years, Docker went from people using it despite of security to now people are using Docker because of security. So I think that's incredibly exciting. And I think the team here at Docker, security team, has been fantastic, and they've all done a tremendously good job.
So whereabouts can people find out more about you, Diogo, and what you do?
Mostly on my personal website, diogomonica.com. And I'm also on Twitter, on twitter.com/diogomonica. Those would be the two biggest ones.
And do you have any recent podcasts or conference talks that you think would help our listeners understand,
Absolutely.
I guess, the most important aspects to focus on around security?
Yeah, there've been a series of really good talks lately from not just me, but all of the fantastic people on my team that I would recommend. I usually post them on my Twitter feed. You also have some on my personal website under the author link, and you can see some of the best ones or the most recent ones, or at least the ones with the best video quality, because there's always recordings that are not that good to put online because you barely can understand what people are saying. But there's a lot of videos there. There's a lot of good resources. The Docker blog is definitely a resource that I recommend everybody going to and following the people on the team.
Cool. Diogo, thanks for joining us today. I really appreciate it.
No, thank you for having me.
Help us make SE Radio even better by completing our short listener survey at www.ieee.org/SE Radio. Thanks. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.